All right, so question 50 should be a lot easier for us now that we've gone through question 40. So let's read question 44, I should say. Question 50 says that this figure shows two planets of mass M and two planets, M and M, and a star of mass big M. The planets are in the same orbit with the radius r, but are at opposite ends of a diameter, finding the exact expression for the orbital period, capital T. Hint, each planet feels two forces. All right. So, sketch it out. Got M, got little m, got little m. Each of them are a distance little r away. So let me think about this one for the moment. Got its force of gravity is going to happen two ways. One, it's going to happen gmm over r squared, and it's also going to happen gmm over 2r squared. That's what this guy will feel. If I do the same process, I'll get the same expression. Gmm over r squared, gmm over 2r squared. So that'll be my expression for the force of gravity on it. They don't give us any actual comparison numbers, so I don't think that we're going to need to find the center of mass, especially because of the symmetries of it and stuff like that. I think they're all circling the same circle, which is good for us. That was the mistake I made in 44. But they're all in the same circle. That radius is r. We're trying to find the orbital period. Well, I'm going to say that equals mv squared over r. Now again, this r is the radius of the circle, and so that is convenient for us because that's already, r is the radius of the circle, so that works out real nice. Now I'm going to swap out that v equals 2 pi r over t. So I've got my m, 2 pi r over t gets squared all over r. M 4 pi squared r squared over t squared, and then I still have that r. So I've got one r that cancels, and the denominator r goes away completely. Over here, I've got g little m over r squared, leaving me just with a big M, a little m over 4, right? Because this would have turned into gmm over 4r squared. Conveniently, I've got a little m that will cancel. So I've got g over r squared m plus little m over 4 equals 4 pi squared over t squared times little r. We want to get time, period, all by itself, so I'm going to move that to this side. T squared equals 4 pi squared r cubed over g quantity m plus little m over 4. Last step, t is the square root, 4 pi squared r cubed over g quantity m plus m over 4. This is a big M, that's a little m. 2 pi root r cubed over g big M little m over 4. All right, that's what I got for question 50.